Hello, my name is Tom Stiles, and this is Tom's Radio Room Show. What you're looking at is the MFJ-223 Vector Impedance Antenna Analyzer. It's an antenna analyzer, and I've been needing one for a long time. And what took place was I was supposed to go to the Orlando Hamfest, and one of the people I wanted to talk to is Richard at MFJ, who has supported my shows in the past and had loaned me equipment to review on my shows, and then of course I returned it or purchased it. And so I did not get to go, but he was nice enough to send me this antenna analyzer for me to review and or purchase to keep for myself or return. So here we go. And as you know, if you looked at some of my previous shows, I need an antenna analyzer. I have one. It's an MFJ, and I've had it for 20 years, and a couple years ago it stopped working. So I haven't had an antenna analyzer for quite some time. So I may end up buying this if I indeed like it. So I'm using my little zip camera so that I can zoom in real close on this piece of test equipment, and hopefully you can see the details of this device. So let's get it out of the box, and then I'll tell you a little bit about it. It comes with the analyzer and a manual, and that's all it comes with. Doesn't come with any cables or anything like that. So there it is. It's got a highly reflective display, and you can see it's about 3 inches by 3 inches by about 2 inches. So pretty small, fits in the palm of your hand. Pretty convenient. It's got a 2-inch by 2-inch screen, color, high resolution screen, and what it can do for you in testing your antennas. And typically this is used by amateur radio operators for testing the antennas that you're going to transmit on, because it's very important that you get your antennas set up properly so that you can get your maximum transmitting distance, plus you don't do any damage to your transmitters. But it also can be used by shortwave listeners such as ourselves for, again, testing your antenna to see if you got a good antenna. I could have used this when I had that broomstick antenna to find out what the heck was going on. So I may end up purchasing this if I indeed like the way what I see. So again, some of the things it can do, it has 2 basic modes. It's got several modes, but 2 basic modes for testing your antenna. One is a single pass mode, a single frequency mode. So it tests your antenna on a single frequency, or a scan mode. So it will scan across a frequency band to see how well your antenna is working across that band. And you can set up what that band is, how wide it is, where it starts, and so on. In the single mode, and it only gives you an SWR reading in that mode. In the single mode, you get 4 readings simultaneously. You get SWR, which is standing wave ratio, which is what we're typically interested in. We want to get that number as close to 1 or 1.1 as possible for a given frequency that we want to listen to. It also gives you the resistance that it measures. Typically you want that to be 50 ohms for our type of receivers. The reactance and the impedance magnitude. And the display is a colored display, and it's very, very easy to read, and I hope it's going to show up on my camera. I tried to illustrate this on my webcam, but I couldn't get it in focus because it's pretty small. Okay, let's turn it on. To turn it on, you push and hold the button on the top. The only buttons that look like buttons or knobs are this one here, and then here is the antenna connection, which is a B and C. Now they don't supply any adapters, so if you're using some other type of connector, you're going to have to get an adapter. And then there's the surface buttons. There's 4 surface buttons to change the modes, to change the frequencies and stuff like that. So let's turn it on by pushing and hold this button on the top, this blue button here. And there it's on. Now, the question is, can I make that readable? Maybe. Still, my camera's still struggling. But above each of these buttons is the particular function, depending on what page you're on. So if right now it's showing help, and it does have help screens, and it's showing system, which will tell you something about this particular piece of test equipment. And in that mode you can put in, which will show up right here, your call sign or anything else you want to put there. And then it's got the single mode and the scan mode, the 2 test modes. So let's go to the single mode by pushing this button right below it. And now you're getting 4 bar graphs. The top one is an indication of SWR. The next one down is an indication of resistance, and then reactance, and then S antenna. And I'm not sure what S antenna is. And then you can set up at the top here, and it probably doesn't show up too well. Yeah, right up there maybe you can see it, is the frequency. Right there is the frequency. Let me get a pin so I don't have to put my fat finger in there. Right up here is the frequency. And in the single mode you need to select what frequency you want to test your antenna to. And it has 4 decimal places to the right of the decimal point. So you can tune it in pretty accurately. Oops, I just kicked the camera. So it's right now it's defaulted to 14 megahertz. And say you wanted, since you were a shortwave listener, say you wanted to know what's going on around 15 megahertz, say for instance. So what you would do is first I don't know if you can see this little yellow dot underneath the numbers. You want to move that over to the decimal point that, or the digit that you want to change. So we want to change that 14 to a 15. So we're going to push down on this button on the top, and it will slide over, and now it's underneath the 14, and I can use the knob now to turn to change that number. So I'll change it to 15. So it's now 15. So the meter is now ready to send out a small signal, as if you were transmitting through your antenna system, and make these measurements. So I'm going to connect up my G5RV, and I'm sorry my camera capability is not too good. So I've got that connected up, and down here above this button is the run start, and so I can push that button and it's running, and it's not showing up on my camera too well. Maybe if I turn the light down that would help. And we turn a few more lights off. There, it's the SWR is almost full scale, which is, it goes from 1.0 to 9.9, and it's logarithmic, and so I would say it's about 5. So my G5RV antenna at 15 megahertz has an SWR of about 5 or 6, which is not good, not very good. The G5RV antenna is very susceptible to how you install it, and mine is not installed very well, and I'll go over that in a short time. Okay, we'll go over that later. Now the next thing this shows me is the resistance at this frequency is about 120 ohms. Again, not very good. You would want it to be 50, and again you want that SWR reading to be as close to 1 as possible. Anything below 1.5 or 2 is good for a G5RV, and then it shows reactance and that other. So you can see it's not very good at that frequency. Now you can dynamically, while it's running, and it's continually testing and updating the display, you can change the frequency while it's running, I think, yeah. So you can see maybe you can see the SWR is changing. So, and I'm changing by a megahertz. So I'm down to 14 now. I'm looking at SWR, which is the top graph. And we're going to tune down. That's up. We're going to tune down. So see, now it's come down. It's the less than 3.0 at 13 megahertz. It jumped up at 12 megahertz, almost up to 9.9, and so on. See if I can find a sweet. Now there's a good sweet spot. It jumped down to about 1.7. That is very good, and that's at 7 megahertz. Now let's stop this for a second. Okay, the G5RV is for mainly amateur radio operators to transmit on, and it's a multi-band antenna, and therefore it's a compromise on all bands. So it's fair on all bands, and it's supposed to be good on 80 meters, depending if you've got the G5RV, which is 102 feet long. 102 feet long is equivalent to 80 meter antenna. So that's where it's supposed to be the best, is 80 meters, which is about 3.8 megahertz. So it was doing pretty good at 7 megahertz. Now we can run it again. Again, I apologize for the poor video. And what I could do, let me just stop for a second, see if I can improve things by raising up my little camera and pointing it down. There, that might be a little better. This camera wants you to be exactly 6 inches away from whatever you're shooting. That's much better. And I'm not running now, so you got no bars there. So I'm going to go back into the run mode. If I get my finger around here, I'm trying to reach around the camera. Now it's running again, and you can see the green bar doesn't show up too well on my camera. Slide the camera around a little more, getting too close there. So it's about 1.6, 1.7 at 7 megahertz, and let me tune down. 6 megahertz, it jumps way up. Talking about SWR. 5, it's way up. 4, it's down. 3, it's not too good. So it's not doing too good. And like I say, later I'll explain probably why it's not doing too good at the frequencies it should be good at. It should be good at about 4 megahertz and below. Below. And it's not. It's about 5.0 SWR, which is not good. Not very good. Of course, we're talking here about reception. We're not talking about transmitting. Now, the other mode, and I'll stop this mode. Okay, we'll go to the other, we'll do a return, which is this button way over here. We go back to the basic screen, and now we can select, I wish I could get this to focus better. We'll select the scan mode, and the scan mode actually gives you a graph of the frequency range that you're going to have it scan. So it goes through, puts out a signal, reads back the SWR, resistance, and all that stuff on that signal, goes to the next one, does the same thing, and repeats that throughout the band or range of frequencies you've selected. And what you do is you select a center frequency where you want the test to be done, and then you select the width of the band that you want to test it over. So let's start at 10 megahertz. So let me dial this down to 10 megahertz. Okay, now it stopped at 12.5, and that's because I've got the band, or they call it the span of the test at 24 megahertz. So I've got to narrow the span down, which is this button right here. So I'm going to push that button and change that. You just push it to change it. So it goes up to 48 megahertz. So let's go on down. Let's do about 6 megahertz. And I'm going to go down to 10 now. Actually got 10.5, so I got to change what decimal point I'm changing. So now I'm at 10 megahertz. So that's my center frequency, and the span is 6 megahertz. So that means it would start at half of that, 3 below 10, which was 7 megahertz, and go to 10 plus 3 to 13 megahertz. Now let's see, maybe we can make that span a little wider. So 12, yeah, 12 would be, minus 12 would be too much. No, actually it won't, it's not too much, because it'll actually go, and I didn't mention that, it will test from 1 megahertz to 60 megahertz. So I'm surprised it let me put 10 in. And with the span is 12, so I have to cut that in half, so it's 6 on either side. So 10 minus 6 is 4 megahertz, which is within its range. So it's going to scan between 6 megahertz and 16 megahertz. So let's hit the scan button, and it will do that test. It'll take a few seconds to do that test. And then there's the graph. So now I can see where my G5RV is working the best. And what you can do is you can take that knob that's on the top, and you can move that line, and that line is what the data is showing at the bottom here. So for instance, down here, I have to use a pin, I guess. And boy, is that out of focus. Down here is SWR, and then there's impedance, resistance, and the other factor. So I can now move that line and find out, see there's a minimum point there, which is what I want on SWR. And that's what you can select what it's showing on the graph, and I've selected the default is SWR. So I can move over to that minimum point, and it will tell me the frequency and all the other parameters. So the frequency at which it's a minimum is 6.92, and the SWR at 6.92 is 1.58, which is very good. Then you can see the rest of the band there. It's not too good until it gets way over there. And let's see what frequency that is. And it finally comes back down again. And that frequency is about 13.3 megahertz. So this would indicate that my G5RV is best at those two frequencies. And like I say, I'll talk in probably the next show about my particular G5RV and why maybe it's not doing too good. So anyway, that's kind of a overall quick view of this little meter. I love the graphic display. I love the fact that you just go in that scan mode and it tries all those different frequencies. You don't have to sit there and turn a knob and read some readout. You just get this nice graph. Like I say, you can push the graph button right here and see the other graphs. There's a graph of the
Good afternoon. The indoor temperature is
nope.
82.3 degrees Fahrenheit. The outdoor temperature is 82.5 degrees Fahrenheit.
Yeah, I don't know if you heard that, but the temperature in my office today is 85 degrees. It really warmed up here in Florida today. It's about 75, 78 outside. So you can go through those various graphs and see a plot of the test results. So anyway, that's the MFJ Vector Impedance Antenna Analyzer, and its part number MFJ-223. Thanks for watching. Bye-bye. Okay.